Okay, so this is ionic bonding. This is a shape or a structure. It's known as a giant ionic lattice. So we'll put that there. Now, giant ionic lattices have positive and negative ions, and that's where an atom has lost or gained electrons to gain a positive or negative charge. So between each ion there is an electrostatic attraction between the positive and negative ions. So I'll stick that there. This electrostatic force is very strong, and therefore a lot of energy is required to overcome this force. Now, if a lot of energy is required to overcome this force, this means that it's going to have a high or low boiling point or even melting point. So we'll put that there. And boiling points and melting points will vary for each ionic compound, but they generally are pretty high. So yeah, giant ionic lattices are solid at room temperature, and that is because there are insufficient amounts of energy to overcome these electrostatic force of attraction, so therefore these ions cannot be broken. Okay, so solubility. Ionic compounds can dissolve in polar solvents such as water. So over here I've got water molecules. Let's just bring them over here. Okay. So each of these water molecules has dipoles. Now the oxygen has a negative dipole and the two hydrogens have positive dipoles. These dipoles are attracted to the ions, so the negative dipoles will be attracted to the positive ions, the positive dipoles will be attracted to the negative ions. So when a ionic compound goes into water, because the giant ionic lattice, or most of them, will be polar, the molecules are able to surround these ions, and this means that the ions are able to dissolve in water. So here we have water molecules surrounding ions and dissolving them in water. Now, one thing I will say is that the larger the charge, the less soluble an ionic compound will be. Yeah, so that's solubility. And one thing I forgot to mention was the fact that non-polar solvents such as cyclohexane cannot break down the ionic compound, cannot surround the ions, because there are no dipoles to attract the oppositely charged ions. So that shows how only polar solvents can dissolve ionic compounds. So we're talking about conductivity now, and I want to say that ionic compounds cannot conduct electricity when they're in solid form, which they're mostly found at room temperature. However, when they're dissolved in water, they can conduct electricity. This is because the solid ions are in a fixed position, so therefore the electrons are not able to move. However, when the ions are in a solution or water, they are then broken up and surrounded by these water molecules. That means that the ions are then free to move in the water, and the electrons are free to move and carry a charge. There we go.